Welcome to our third to the last section of notes in Math 091. We're almost there, guys. So this section deals a lot with parallel and perpendicular lines. I believe I put about 4 questions on the Module 7 test and 2 or 3 on the final exam from this section. So let's go ahead and get started. So parallel lines. So we look at this and we go, how did they graph those lines? This is actually a graphing calculator screen, but remember how we learned this means the y-intercept is 0, -4, and you can see right there, 0.0, -4 is there, and the rise is 1, 2, 3, the run is 2. Boom. So there's that line. And this one, our y-intercept is 0, 1. And for both of these, let's just write rise over run is 3/2. So 0, 1, there's the point, and then rise 1, 2, 3, run 1, 2, boom. So that's where those two lines came from. This is just a picture of a graphing calculator screen, but that's where the two lines came from. Make them just like you have all throughout the module. But what you should notice is that these lines don't intersect. They never cross. So we call those parallel lines. And we learned this in Module 6, and I had you highlight it, but I think I would highlight it again. Parallel lines have the same slope. So once we get it solved for y equals mx plus b, and there's questions on the test that aren't solved for y, so you have to get y alone first by doing the opposite and getting alone, which you'll see here in the example below. So once you have y alone, then you compare the slopes. If they're the same sign, same number, then we can say the two lines are parallel. When two lines don't intersect, there's not a point in common between the two lines. Therefore, we call that an inconsistent system. Because I just think of it as consistent means, what's the norm is when two lines cross and you find the point. So I think of this as being inconsistent because it's not the norm. The lines don't cross. So inconsistent system. So let's look at an example of this, and this is very similar to what I put on the test. Like I said, I put 3 or 4 parallel and perpendicular questions on the test. So here's a second scenario. We have two lines. Notice they are in, do you remember that's called standard form, ax plus by equals c. So both lines are in standard form. And so in order to look at the slopes, you have to solve them for y. So this is what I was saying on the test and on the final. There's some that are not solved for y. You can't tell what the slope is until you get y alone. So that should be your number one job. So here's the first one, 2x minus 6y equals 12. So we need the y to stay there. So we're going to subtract 2x from both sides. And then that will cancel. And you get -6y equals, and in Module 6 we learned how to change the order so the x was first, keeping the sign with it. So -2x. And then 12 doesn't have a sign in front, so it remains positive. Then this is the step, and I want to do this out here so you can see it. So -6y equals -2x plus 12. And this is a step more students miss than any, so that's why I want to make sure you know how to go from here to there. So to get y alone, we're doing the opposite as we stated. And the opposite of multiplying by -6 is dividing by -6. And hopefully you remember from Module 6, when we do this step, we have to be sure and do it to every single term all along the way. So negative divided by negative is positive. 6 divided by 6 is 1, so 1y, which is just y. So here's where you need to be careful, because Alex will count it wrong. So would I if it was on a paper pencil test, if these numbers are not simplified. If you're not good at simplifying, then divide them out on your calculator. But I think these should be easy enough you can do them in your head. So 2 negatives in division is always positive. So make sure you make that positive. It is not a negative slope, and you can see the lines rising from left to right to verify that. 2, 6 can be simplified by 2. So 2 divided by 2 is 1. 6 divided by 2 is 3x. And as long as you make the signs positive yourself, 2 negatives equal positive, then in your calculator you can just type in, and I know this one's easy, but if you had a harder one, you could type in 2 fraction bar 6 and it simplifies it for you. It just won't let you put the negative in the denominator, so that's why you would need to clean that up first, then type it in and hit enter. And 12 divided by negative 6 is negative 2. 1 negative is a negative. 12 divided by 6 is 2. Excuse me. Okay, so that's where they got that line. So if we go to the graph and graph it, we have 0. Well, let's write it. Y-intercept 0, negative 2. Rise over run is 1 over 3. So let's get over here a little bit. Plot 0, negative 2. And we rise, run 1, 2, 3. And that's where this line came from. Arrows on both ends. Okay, now let's do the other line. I'll do it in a different color. So here's the second line. And we're trying to determine whether they're parallel, perpendicular, or neither. So 3x minus 3x minus 9y equals 18. We need to get the y alone, so leave it and do the opposite of what's in front of it. It's a positive 3x, so we subtract 3x from both sides. 3x's are gone. So then we're left with negative 9y. Then we want to switch the order of these and remember to carry the signs with it. Negative 3x, positive 18. So here's that step again, and I want to do it over here just because, like I said, so many students miss this. So I want to make sure you guys are clear on how to do it. So negative 9y equals negative 3x plus 18. So again, just like the previous problem, we need to do the opposite of multiply by negative 9, which is divide by negative 9. So 2 negatives equal positive. 9 divided by 9 is 1. So we get 1y there, which is what we want. 2 negatives again is positive. And here we can see there's a 3 common. And like I said, on Alex, and if you were taking a test in the class, we take points off. I think Alex gives half credit or maybe takes it all off. I'm not sure, if your fractions are not simplified. So you have a calculator right by your side. If you're not sure whether it's simplified, type it in and it will tell you. So 1/3 x minus 2. And there it is. But look what happened. We had 2 totally different lines and they turned into the same line. Oh my goodness. So guess what we call those? We call those coinciding lines, which means one line is going to graph right on top of the other line. Because isn't this y-intercept 0, negative 2? So we do that here. And rise 1, run 3, we do that there. See how the lines are right on top of each other? So those are called coinciding lines. So once we get the two equations solved for y, we see they are equations of the same line. One line lies directly on top of the other line, so we say that they intersect at all of the points on the line. So does everybody agree? Every single point on this line is a point of intersection because one line is right on top of the other line. So how many solutions do you think they have if they intersected every point on the line? Lines go on forever in both directions. So wouldn't you say they have an infinite number of solutions? So every single point on that line is a solution, plus the lines go on forever. So coinciding lines have an infinite number of solutions. And we call this a dependent system. And you know how I always make up tricks to remember stuff. So up here, I said you can remember inconsistent because our most common situation is when two lines cross in one point. So when they don't cross at all, that's not common. So that's how I remember inconsistent. On this one, it's easy to remember because one line depends on the other line because they lie right on top of each other. So that's how I remember dependent. One line depends on the other line because they're the exact same line and they lie right on top of each other. And again, they have an infinite number of solutions. The reason being, every single point on the line is a solution because they share those points. On this, we have no solution. And I think I forgot to highlight that. I should have. So parallel lines have no solutions because solutions are, let's write that up here because that's one thing I realize some students don't know. A solution to a system just means two or more equations. To a system is the point or points of intersection. Wonder if I can squeeze that in. Intersection. Barely. So when I say find the solution to the system, I'm asking you to find the point or points of intersection. So because there's no points common here, this would be no solution. And you might even want to write why. No points in common or no intersection points, whatever you want to write. Because it's the points that they have in common or the points where the lines intersect that are the solutions. So that's a pretty big vocabulary word because you need to understand that in order to understand what it means to solve a system. So you're looking for the point of intersection. When there are no points, we write no solution. On coinciding lines, there are so many points in common, we can't even count them. So we call this infinite solutions on the line. Infinite solutions on the line y equals 1/3 x minus 2. So you're probably like, why can't we just write infinite solutions? Well, that means this would be a solution, and this would be a solution, and this would be a solution, and they're not. All the solutions are on that line, not anywhere on the graph. They're still an infinite number because they go left forever and right forever, but they're specifically points on that line because those are the points the two systems or the two equations have in common. So we write infinite solutions on the line, and then we write the line that both of them turned into once we got y alone or put them in slope-intercept form. So parallel lines, no solution. Coinciding lines, infinite solutions on that line.